In this video, I am going to discuss ECS Network Mode, the available options, and their applicability. Container networking refers to the ability for containers to connect and communicate with each other, or to non-Docker workloads. This is the definition provided by Docker, and it's applicable for ECS as well. Let's take an example of our to-do application, which is running as an ECS task. You have another containerized application, called Reminder application, which is also running as a separate ECS task. Every time a to-do entry is created with a reminder, to-do application need to connect with the reminder application. You must have a container network set before you can make such call. This is an example of an internal communication, but your container needs to be available even for an external communication. For instance, from a load balancer, API gateway, etc. For both internal and external communications, your task instances need to exhibit a networking behavior. This behavior is configured by specifying the network mode while creating the task definition. Typically, when you access an application or a service running remotely, you need an IP address and the port number at least to access it. The same principle applies to our task instances as well. By default, when the task instance is created, the container functioning inside remains in an isolated zone. You need to enable the network mode so that you can expose your containerized application for any communications. ECS supports 5 possible options to set as the network mode. This includes host, bridge, AWS VPC, default, and none. Let's look into each of these options in detail. Host mode is the most basic network mode. It's applicable for the Linux EC2 instances only. In this mode, the networking of the task, or container, is tied directly to the underlying EC2 instance. When you create an EC2 instance, an elastic network interface gets attached to it. The elastic network interface, also known as ENI, is a software networking component, which has its own IP address, MAC address, etc. In the host mode, when the container runs on EC2 instance, the container network gets linked to the ENI, attached to the EC2 instance. Additionally, your container port automatically gets mapped to the same port on the EC2 instance, also referred as host port. For instance, if your to-do application container is running on port 3000, it will be mapped to the port 3000 of the EC2 instance. In this mode, if you want to access the task instance, you just need to specify the EC2 IP address and the host port, which is same as the container port. As already said, this mode is applicable for Linux EC2 instances only. The biggest challenge with this mode is, you cannot create more than one task instance of the same task definition on the same EC2 instance. If you create more, you will end up in the port conflict. This is because the first instance is already mapped to the matching host port. Port conflicts can also occur if other applications or microservices are running on the same port. If you are deploying multiple applications or microservices on the same EC2 instance, you need to ensure each of the applications are running on a distinct port. With bridge mode, you create a network bridge between the host and the container. This bridge helps in creating a port mapping between the container port and the host port. Container port and host port could be different in this case. For instance, for the to-do application, you can map the container port 3000 to the host port 80. With this configuration, you can access the application by specifying EC2 IP address and the host port, which could be different than the container port. You can define the port mapping in either static or dynamic form. If you are choosing the host port yourself, like we just did, this is referred to as static mapping. Challenge with the static mapping is similar to the host mode. You cannot create multiple task instances on the same EC2 instance. If more than one task instance is created, it will run into port conflicts. The other way to create the mapping is dynamic. In this, you do not set the host port. At the time of container creation, the Docker chooses a random, unused port from the range and assign it as the host port. You can access the application by specifying EC2 instance IP address and the allocated host port, which in this case is 34567. If you create another task instance, a different port will be allocated as the host port and mapped to the respective container instance. The bridge mode with dynamic mapping enables us to run multiple task instances. ECS keeps a track of these dynamic ports and update the dependent APIs automatically. For instance, if you are using load balancer, it will automatically update the target groups with the dynamic port mappings. If we talk about the applicability, similar to the host mode, bridge mode is also applicable for Linux EC2 instances only. You can run multiple task instances with the help of dynamic port mapping we just discussed. One disadvantage with bridge mode is its difficulty to restrict the service access. Because of the dynamic port mapping, you cannot specify a network access rule based on a specific port. AWS VPC mode is the recommended mode with ECS. With this, each of the task instances get its own elastic network interface, or ENI. Each task ENI is assigned a private IP address based on your VPC configuration. When you receive communication from outside, you connect to the task ENI directly. You can do the static port mapping in this case. As each of the ENI have different IP addresses, you will not run into any port conflicts. If you are using AWS Fargate, this is the only mode available to it. With Fargate, it works in a similar fashion. For every task instance, you get a dedicated ENI, which can be accessed from outside, directly. If we talk about the applicability, unlike the host and bridge mode, you can enable this mode for all the supported ECS platforms, including AWS Fargate, Linux, and Windows EC2 instances. With this mode, you can run multiple task instances on the same EC2 instance. As you are getting a separate ENI, with a separate IP address, you can attach a separate security group to it. You can specify the networking rules in a more restrictive manner, which in turn enhances the security of your containerized applications. You can monitor the task instances in a more granular manner, with additional features like VPC flow logs. We will discuss this later in the course. The only challenge with this mode is the limited quota for the number of elastic network interfaces on EC2 instances. For example, by default, with C5.large instance, you can attach up to 3 ENI only. One ENI is dedicated for EC2 instance, which means only 2 ENI are available to run task instances. As each ENI is mapped to one task instance, you can run only 2 task instances on C5.large instance. You can increase this limit with the help of ENI trunking feature of ECS. We will discuss this feature later in this course. Please note that this limit is only applicable for EC2 instances. Default mode is applicable for EC2 Windows instances only. This mode uses Docker's built-in virtual network mode on Windows, which runs inside each EC2 instance, hosting the task instances. The built-in virtual network on Windows uses the NAT, which is the Docker network driver. Any task instance running inside the Windows host will be accessed through NAT. This is the default network mode on Windows EC2 instances. Alternatively, you can select AWS VPC as the network mode. If you are choosing network mode as none, no communication can be established with the task instances. This might be applicable for the containerized applications, which can run independently. Here is the compatibility chart for all the network modes, across all the launch types and operating systems. If you are using Fargate, only AWS VPC mode works for it. If you are using Linux EC2 instances, then all the network modes are applicable for you, except the default. If you are using Windows EC2 instances, then you can enable either default or AWS VPC as the network mode. Though you can use different networking mode depending upon your use cases, ECS recommends to use AWS VPC as the network mode for your containerized applications. As we already discussed, this is applicable for all the supported runtime platforms, including Linux EC2 instances, Windows EC2 instances, and AWS Fargate. Additionally, it helps in enabling enhanced security and monitoring for your containers.